Okay, lots of buttons. So we're going to talk about statistics today, displaying data, and all of the things that go along with it. How we can see things given to us. You guys are probably, if you watch any bit of the news right now, you're probably seeing a lot of information on the news regarding statistics and some measures and how they calculate things, all having to do with coronavirus and vaccine testing and all of that kind of stuff. So this does have some real applications, and um, how they use this information. So let's take a quick look. Now I believe I gotta grab my paper copy of this really quick. I really wish I had a better organization process than I currently do. Aha, I found it. Okay. I just wanted to make sure that you guys, if you have your paper copy or if you have the PDF copy, this is all filled in. You don't have to worry about adding anything in there. So this is on page 17. So we're going to talk about measures of central tendency. So how we kind of centralize or group data into this subset. So when we talk about class averages, we're talking about the centralized, what we all kind of revolve around, and there might be some people kind of on the upper end of that average and some people on the lower end of that average, but that's where how the average gets calculated. So that would be referring to statistics. They tend to summarize and compare sets of data. The mean is the average. Hi. Parker says hi. Is your average set of numbers, adding up all the numbers and dividing by how many you have. We have, and we're going to talk about that in just a minute. That's the abbreviation, I guess you could say, for the word mean. Oh, you know what? I don't have my copy of this all filled out. The median is your number in the middle, your mean, your median, and then we have our mode, which is the number that occurs most frequently. So this is all stuff that you've talked about in middle school even. I don't think it goes through our Algebra 1 curriculum, but you've heard it probably a ton of times, but this is a just nice quick review before the SAT, which I know is not until, and some of you actually seniors from last year took it earlier this semester, but yeah, it's a good review for you guys before. I guess it's not till April, but measures of dispersion. So central tendency would be our mean, median, mode. Any kind of calculation of statistics, we try to think about that centralized thing. When we talk about dispersion, we're talking about how spread out the data is. So the range would be one thing that tells us the amount of data, how from the lowest number to the highest number. The standard deviation is also something we're going to talk about. Talks about how from the center of the data, how far statistically it seems that the data tends to move away from that center. So we're going to talk about that today too. We see a lot of standard deviation having to do with, it's called a bell curve, where we have here's the center, and then we look at some data and how these like percentages of information is distributed. So we're going to talk about that towards the end of the notes. So to start with, this is actually for my last year's class. I'm sorry, guys. I did not have a lot of time. Seems like everything takes a lot longer than it used to, and so I did not have this updated for this year. This is actually for my A4 class last year. These are their birthdays, days of the month that they were born, to see, kind of do some of this calculation. Is there anything that happens or that we see as centralized? So this is a lot of students. Yes, we can calculate all of this information mean, median, mode, range. We can do all of that by hand. Standard deviation we can, but there's a big formula equation that we don't like to try and do because it's a lot. So we're not going to. I'm going to show you guys how to do this in the calculator. So the mean, what I would do if I wanted to calculate this, I would take all of these numbers, I would add them all up, and it looks like I have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have 24 sets of data here. If I wanted to find the mean, I would add all 24 numbers up and then divide by 24. If I wanted to find the median, I would need to list all of these numbers in order, lowest to highest, and then I would look for the middle value. The mode would be the number that occurs most often. Our range, and this one, I am going to show you how to do this one in just a second, is the lowest number subtracted from the highest number. So I'm going to write these underneath. So if you don't have a calculator, if you don't have access, you can do most of this information. So I'd add the numbers, divide by 24 because there's 24 numbers total if I wanted to find the mean. The median, we would write them in order. And then find the middle. Oops. If there's two numbers that are in the middle, then you just split the difference. What's in the middle of the middle? The mode is the most. And the range is the difference between. So, okay. So I have all of this written out and you're like, okay, where is she going with all of this? So you can use your calculator if you have a graphing calculator. I've got the directions listed here for how to do this. If you don't have a graphing calculator, then I'm going to show you how to do this on the Desmos calculator. It's basically the same steps. In the TI-84 in this calculator, there's a stat button. It is, you've got your second, and then underneath the second, you've got alpha, and it's the third over. There's the stat button. It's right by the arrows. But if you don't have, oh, there we go. There we go. If you don't have a stat button or a calculator that has the ability to do stat, then you would just go in here and edit. So this is basically the same thing. You would hit edit in the graphing calculator in the TI, and you would get a table very much like this one that you see here on my screen. And so then what you're going to do is you're just going to enter all of this information into the table. Now, obviously, I don't normally give you 24 pieces of information. I'm just doing this so that you guys can see that it works no matter what. So I'm going to enter all of these numbers. So I have 4, 12. I'm just arrowing down. 6, 10, 14, 31, 6, 25, 27, 24. This is probably the part that takes the longest. Is just 3, 24. Entering the data in. Okay. So oh, dang it. Don't hit enter. Hold on, I gotta do that again. In the calculator, you can hit enter. It's no big deal. In the Desmos, this is the one thing I learned. Okay, there. I can arrow down, I can tab, I can't hit enter. Okay, so I've got all my lists entered. So now what I'm going to do, and you would do the same thing in the graphing calculator, once you have it all entered, you're going to press your calculate. So in the main menu here, I'm going to go to my calc menu. Okay. So if you were doing this in your stat calculator, if you were doing that in here, you'd have your stat, and you would scroll back over to calculate. So at the very top there, it says calc. And we're going to do one variable statistics. There's all these other types of regressions that we can do. We're going to actually talk about that at the end of the year. But since I know right now not everybody has a graphing calculator in front of them, this is the next best thing. So I'm going to do one variable statistics. You would do the same thing in your calculator. It's the very first option in the calculator. You just hit enter, and you really don't have to change anything that's in here. So we would just go down to calculate. And we get all of this information. So I'm going to grab this just because it's easier. And we need to know, what does all of this stuff mean? So I'm going to paste that on this picture here, this image, just so that we have it. So what's the word for all of these things? What are all these things meaning, so that we can then come back up and answer the question that was asked of us, which is, tell me what this stuff is. So here again, here's all the directions, and we have these same symbols, same numbers. I realize mine has the double bar on it. It's just a typo, not a big deal. This is all these pieces of information here are in the Google Classroom. So the X bar that you see there, that's the mean. That's adding up all of the numbers and dividing by however many numbers there are. So in our calculator, we see that the mean was 16. So I'm just going to kind of add these things. It looks like a really big E. That's the sum of all of the items in the list. So if I added up all 24 numbers, I would get 384. The X squared, you're not going to worry about. It looks like a weird O. That's actually the standard deviation. These are both types of standard deviation. We're going to only work with this, it's called mu. We're going to work with that number. And that's because it has to do with population and the people, as opposed to the other one, which I think is percentages. I can't remember. I don't use it ever, so. The N is referring to the number of items in the list. We knew that there were 24 items. We had counted that earlier. So there's 24 numbers in the list. And then this stuff at the end, the min, as it might sound, that's the smallest number in the list. So the minimum is 2. Q1 refers to quartile 1. I'll talk about that more in just a second. 7.5. Med refers to medium, median, not medium, median. Q3 refers to quartile 3, or the top 75% of the items in the list. And the max, which is exactly what it sounds, that's your largest number. So the highest number in the list is 31, which makes sense because there's 31 days in a month. So I have all of these numbers. So now if I want to come up here to my question again, I can answer my numbers now. I can answer the question. So it asked, what was the mean in this problem? And so we found our mean to be 16. If we wanted to calculate it again, we could have added all the numbers up, which would have added up to 384. If you want to calculate by hand. So I could just do 384, which was the sum of all the numbers in the list, and divide by 24, and I could just verify that that is in fact the mean. The median, that's the number in the middle. I don't know if I lost connection for real or if I only pretend lost connection, but my computer just like told me I lost connection. Oh, it appears as though I froze on your computers. I'm looking at GoGuardian. Totally. Awesome. Just waiting for my internet. Oh. It's like every day. I don't know why. Okay. So, my son gets out of quarantine on Thursday, so I'll be in the classroom on Friday for class. I mean, we only have like a 60-minute class on Friday, and again, it's going to be just kind of wrapping up anything that we might still need to talk about if we have to do anything, depending on how long notes take tomorrow. Getting anything turned in, asking any questions, maybe playing a game. I think that could be fun. But hopefully, we'll be in the classroom on Friday to actually get to do something with some reliable internet. That'd be great, right? Let me try that again. Okay. We got this. Totally. Okay, so like I was saying before I got cut out, the mean is just adding up your numbers. So we had said that our sum was 384 from our list, from our calculator, or you could add them up by hand and then divide by the number in the list. Our median, if we put them in order, which again, 24 numbers to write them in order is kind of a pain in the butt. So that's why we're going to let the calculator do it. If it was only like 5 numbers, oh, it'd be, a piece of cake. It'd actually be faster to write them by hand than to write them in the calculator. But it's really nice that the calculator will do that for us and find our median. So it's saying 15 would be the middle number in the list of numbers. The mode being the one that occurs most often, we could go through and look what number do we see the most, or we can go and look. Oh, actually, no, I was thinking that was in there. So I guess we're going to have to go in to our list and look at what number occurs the most often. And that also, when you're writing them in order for the median, then you can see your mode come up a lot too. So let's see here. I've got 4, 12, 6, 10, 14, 31. So I can see I have a 6 here. I have a 6 here. 7. I think the 6th is the one that comes up the most often, but I'm going to double check. I see a 10. Any other 10s? There's a 10. Just trying to see if there's something else. 12, 14, 31, 25, 27, 24. Trying to see if I see anything. Oh, there's a 24. There's a 24. Oh, and there's a 24. So that number comes up more often than anything else, because I see a 27 again, and there's a 27, but there's only 2 of them. So I'm looking for the one that occurs the most, and it appears that 24 occurs the most. You can have multiple modes. We call it bimodal, which we'll actually talk about in just a little bit, where you have, this 3 different numbers come up, or I guess bimodal would be 2 different numbers come up 3 times when everything else is less than that. So you can have bimodal, you could have trimodal. So the mode does not get split. The median, if you list them all in order and you get like a 10 and a 12, then 11 would be the median because that's in between your 2 numbers. The range is the difference between. That is also something the calculator does not find for you. So the range would just be the highest number minus the lowest number. So it does tell us our minimum and our maximum. Our minimum was 2 and our maximum was 31. So all we're going to do to find our range is subtract 31 minus 2, and we get 29 as our range. So there are 29 from the lowest number to the highest number, there's 29 spaces in between. And then our standard deviation, which again is a big formula. You get this crazy decimal that comes out. And that's this mu is how you pronounce that. And that is 9.09. So that one is not something you're going to calculate by hand because of how big the formula is. It is possible, but you don't really want to. Just saying. Okay. So again, most of that can be done pretty quickly. And again, our list is longer than most. I think on the homework, I give you like 6 questions, 6 steps, or 6 numbers, I mean, in a group, so that you don't have as much to do. Oh, there it is. Yeah, what do I, okay, no, it's more than 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on the first one. 4, 5, 6, 7, 8. 10, 12. So up to 12 is the highest number set that I'll give you. So you don't have as much to deal with. Yeah. And there's only, oh, I'm sorry, this one does have a lot, but it's okay. So we're going to look at some statistical graphs. And this is where more often you're going to see a lot of stuff come up with the SAT, where they're going to give you, especially this one right here. It's called a contingency table. That one comes up all the time on the SAT. So being able to read it and understand what it's asking you of or asking you about, that's going to be something that's going to be really helpful for you. So a frequency table shows the frequency or how often. So if we were looking at like listing out our numbers, we could say, let me go back here. What was so like the number, so we would like 4, and we would have a tally mark. So it's something we do a lot with tally marks or dots or numbers. 5 would have a 0, 6 would have a 2, 7 would have a 1, it looks like. 8 would have a 1, 9. You would go through, when you get to 24, you would put 3 marks or put a number 3 next to it. So it's kind of like a tally. That's the easiest way to do a frequency table. A contingency table, which is what you see here. This is basically, it sets up all of the information to kind of distribute between different types of people. So thought for a second I had something on my face. It turns out it was on my computer, and I could see it. It was like right on my camera on my face. I'm like, what is that? Okay. Anyways, so like this is actually, this contingency table that we see here has to do with the Titanic and the people who survived or did not survive the hitting the iceberg and all of that stuff. So we can see that, there were 202 people in first class who survived versus 123 out of 325 total. So it's just kind of telling us some information in a chart that makes it more easy to read as you're distinguishing between all of these pieces of information. A box and whisker plot. We're going to do one of these here in just a second. It looks like this. Where we use a lot of our quartile data. So this would be our median. Here we would have our Q1, here we would have our Q3, the numbers, and then this is your minimum and your maximum. So it's going to look like that. It encloses the middle section of data. And so basically from your lower 25% to your upper 75%, you can see where 50% of the data comes in to play in that information. So we're going to talk about that and create one here in just a second. A stem and leaf plot. You guys might have done this in like elementary school even. A stem and leaf plot has a lot to do with breaking up your 10s and your 1s. So if you think about a stem and leaf plot, let's see here. If we said these would be your 10s place, these would be your 1s place. So it's another way to calculate data. So if I wanted to say, if I had the number 10, 15, 17, this is just be another way of writing the number 10, 15, and 17. So basically to try and shortcut it. If I said 22, 23, 26, that would be these numbers. It's just a different way of writing it. So being able to read one of those tables is important. Writing them is not as big of a deal, but being able to read it and know what it's talking about. A histogram is just a bar graph. You've done bar graphs. I'm hoping you've done bar graphs like a lot, right? So it looks like this. There's a bar graph reading that data. So we're going to create a histogram today. A frequency polygon is just another word for a line graph. So if you've got your table, hopefully it doesn't look like that too much, but it's just you got your points plotting, you connect the dots, that kind of thing. A segmented bar chart is where you stack some data on top, where you're comparing a lot of the different things. Here again, this is dealing with the number of people alive versus the number of people dead, and the class of the ship that they were in, first class, second class, that kind of deal. So we'll talk about that in a second. And then finally, a pie chart. Hopefully you've read a pie chart before. Again, here, same statistical data. The number of people in the crew, the number of people in third class, second class, first class. This is just the total. It's not segmented into also alive versus dead. So, so pie charts can't distinguish as much information. So to create a box and whisker plot, if you don't have the data on your calculator already, you would organize your data from least to greatest, find your minimum and maximum. You would find your median, which would be your middle value. Your lower and upper quartiles would be halfway between the median and the lowest number, or halfway between the median and the highest number. We plot them on the number line and then draw the box and whisker plots, and we'll talk about that too. So you guys have a big space here. It says just draw a box and whisker plot for the birthdays in Mrs. Kane's class. So we already knew some of this information. In fact, I'm going to paste it here again just so that I have it. So the information we need, which is actually pretty cool, is all of this stuff at the bottom end. We need to know the minimum. We need to know the quartile 1. We need to know our median. We need to know our quartile 3. And we need to know our maximum. If you haven't calculated it, you would calculate it either using your calculator or, come on, oh, my computer froze, cool. Try it again, delete, there we go. Oh, you know what? I can't delete that yet, I need to know what those numbers are. So our minimum we knew was 2, our quartile 1 was 7.5, our median is 15, our quartile 3 is 24, and our max was 31. Now I can delete that. So to draw a box and whisker plot, I'm going to start at 2. Technically, we would draw this out on a number line, but I don't really want to. Let's see here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to mark that because that's going to be important. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, I got to shorten this up a little bit. It's not that bad. There. There's my 31. Oops. Maybe not. Try it again. 31. Okay. So to draw a box and whisker plot, we start with our minimum and our maximum. Our quartile 1, 3, 4, 5, 6, 7 and a half. So here's our Q1 at 7.5. Our median would be at our 15, and our quartile 3 is at 24. 16, 17, 18, 19, 20, 21, 22, 23, 24. And we basically just draw a box that connects them. So what this is trying to tell us, let's see here, this would be the whiskers. So the whiskers are kind of the extrema, I guess you could say, the ends of the line of the graph. 50% of the data falls from quartile 1 to quartile 3. So from 7.5 to 24, 50% of the data is in that range. So that's kind of the reason that we have the box there is to say that's the bulk, where most of the information is. And we can see here when we look at our median that it's not evenly distributed. It's more heavily weighed towards the left because the median is slid to the left a little bit more. So not a lot, but just a little bit. It's, there's 9 units from 15 to 24 as opposed to 7.5 units to the lower end. So it leans to the left a little bit. It's for that information, I guess. I don't know how else to say that. If you were trying to find your quartile 1 by yourself or by hand, what you would do is you would find halfway between your 2 and your 15. So you would basically find the median of those two values in order to calculate that. So it's not that you're adding 2 and 15 and dividing by 2. It's that you would have to list all of the numbers in from 2 to 15, and you're finding the middle or the median of that set. Same thing, from 15 to 31, you would list all of the numbers from your data, and you would look for the median of that set of data too. So it's like the median of the median, if that makes sense. So it's just faster if you let the calculator do it for you, though. Oops, too far. The next one is the one where it got kind of cut off. You're supposed to be in your class. Go.
No, Miss Connor's reading with Cannon.
Oh, okay. And then you have your 8:50 meeting?
Yeah.
Yeah? Okay. All right. So I realized that this got cut off on your paper. The graph part got cut off. And we're just going to kind of draw. We're going to sketch something in here, so it's not that big of a deal. We're going to create a frequency table using that same information. So frequency table, remember that was like the tally marks. So if I do tally marks for this, we want to know our intervals, they have to be the same size. That's the big thing with our intervals. In this case, we're going to say our interval is from 0 to 6. You could make intervals of just numbers. So like 15 is my interval, 16 is my interval, 17. So like you're just counting individual numbers. Since we don't see a lot of repetition in these numbers, we're not going to worry about a single value. We're going to look more at a big group of values. So we want to tally all of the numbers from 0 to 6. So let's see here. I've got 1, 2, 3, 4, 5. I almost got that one. I almost marked to the 7. So I know there are 5 numbers from 0 to 6. So it's just going through and doing a tally to come up with all of these numbers. So I'm going to look for all of my numbers from 7 to 12. So there's a number 1, 2, 3, 4, 5, 6. So I have 6 digits, 6 numbers, 6 values between the numbers 7 and 12. From 13 to 18, 1, 2. Oh, wow, that's it. There's only 2 digits, 2 birthdays between the 13th and the 18th of the month. From the 19th to the 24th, so 1, 2, 3, 4, 5, 6 again. from the 25th to the 30th. So I've got 1, 2, 3, 4, and then it's technically the interval would be the 31st to the 36th. Obviously, there's not 36 days in a month. We'd only have the 31st, and that would be just one number. So that's our frequency table. That's how you do one of those. And then a histogram, which is just, again, basically a bar chart. So I would just create, and I realize, again, you guys don't have the chart here, but that's okay. A histogram is just a bar chart showing this information. So if I wanted to say the numbers from 0 to 6, I would list 1, 2, 3, 4, 5. Actually, I'm going to change that to red so that it matches my data. And I could fill that in too. Yeah. You could put a 6 on top if you want, because I know, again, you guys, you're the computer. Oh, why did I do that? 1, 2, 3, 4, 5. I put 6 on top. The numbers are from 0 to 6, but there's only 5 numbers from 0 to 6. I think that's what got me confused. From 7 to 12, so from 7 to 12, I have 6 pieces of information. There's where the 6 goes. You don't have to color these in either. From 13 to 18, I have 2 pieces of information. From 19 to 24, back up to 6. And from 25 to 30, I had 4. And I need one more color here. How about orange? That'll work. From 31 to 36, we only had 1. There. So that's all a histogram is. It's just a bar chart. And I realize that you guys don't have the grid there. I believe the grid is on your homework, though. You have to do one of those, which isn't that terrible. Okay. A stem and leaf plot. Moving right along. Which is just our ones place and our tens places to see or to configure that information. So if I want to do a stem and leaf plot, the stems, that's your tens place in this case. And this would be our ones. So with this, because we do have numbers that are not in the tens place, we could say our first stem is actually a 0. And then 1, 2, 3, because there would be numbers that are from 0 to, kind of think of this as like 0 to 9. This would be our like 10 to 19. These would be, the 2 would be like our 20 to 29. And then the 3 would be our 30 to 30, well, it'd be 30 to 31, but 30 to 39 technically in this. So that's all we're looking for. So it's kind of like the frequency table again, except that our values are going to be slightly different. So if I want to list these all out, I'm going to put them as much as I can in order. So I have a 4, I have a 6, I have another 6, I have a 2 and a 3. I knew that I was going to have those, so I was going to put those in the front. You don't actually have to put commas in there. Oh, I got an 8. Oh, and I have a 7. I missed my 7. Let me see here. Okay, so there's all of my stem and leaves. So my stem being 0, meaning there's nothing in the tens place. And then the leaves, those are my numbers 2, 3, 4, 6, 6, 7, and 8. So it's also another way to kind of help list your digits, your order for everything. So then from my stem from 10 to 19, I have my 10. So I'm just going to put a 0 in place. So that way it has 1 and 0 makes the 10. I have another 10 over here. So I'm going to put another 0. I have an 11. So I'm going to put a 1 there for the 11. So I'm just putting the ones place on it, not the whole thing. It looks like I have a 12. So I'll put a 2. Scanning through, I don't see a 13. I've got a 14, so I'll put a 4. I've got a 16. I'm just looking. Doesn't look like I have anything 17, 18, or 19. So then I'll look into the 20s. Let's see here. I have a 20, so I'll put a 0 for 20. I have a 21, so I'll put a 1 for 21. I have a 22, so I'll put a 2 for 22. Doesn't look like I have any 23s. I've got a 24, and actually I knew I had 3 of those. So this is another way to also see what your mode is, because I can see I have 3 4s. That's 3 24s, more than I have of anything else. I have a 25. I have a 27 and another 27, so I'll put 2 7s down. And that looks like that's it for those. And so then for my 30s, I have a 30 and a 31, so I'll put a 0 and a 1. And that does it. There's all my numbers. So that's how we read our stem and leaf plot. So again, it kind of looks weird, but when you get used to seeing it, it's actually pretty easy to kind of help you categorize and list all of your numbers in order. Okay. These next ones are just different ways of looking at distributions, different types of graphs, basically. Oh, I don't have anything here. I'll have to type these in. Let's see here. We'll do this in blue. So, binomial distributions. Move that over there for a second. Oop. You gotta remember all the names. Okay, that's what I thought. I'm like just trying to make sure that I do this right. Okay, so we have different types of graphs. This actually is going to come into play more tomorrow, where we're just saying what kind of graph is this. So this is a bimodal graph. You guys have lines for it to actually write them in. I don't have my lines. So this is a bimodal, and that's because we can see there's 2 different towers. So that's how we know it's a bimodal distribution. The next one is pretty much a uniform. It's all pretty much even. So we can see it's mostly the same. On this third one here, we call this a standard or a normal or symmetrical distribution, where it kind of goes up and then back down. So you can see here it even says fold along the dotted line. It looks like it's pretty symmetrical, that it's the left side and the right side match. This is a folded distribution. Think of it like it's the folded on the line of symmetry. It's half of the normal. I had to change my settings here. There. That's all right. This third or this fifth one, I guess, the one on the bottom here, this is a graph where we have outliers. I'll scroll up here. There are parts that are just separated out from the group. Here we go. So like right here, these are outliers. That's something that a lot of statisticians, people who look at statistics, they look for outliers. Is there something that doesn't fit with the trend, with the data? They looked at a lot of information when they're looking at the COVID-19 vaccine. They were looking for outliers. They were looking for, is there something, especially when people were reporting their symptoms and things, is there something that doesn't fit? Is there something that we should be watching out for? Is there something where a lot of people are reporting the same thing? Those would be the symptoms that they're reporting. There was a time back in, I think it was the end of October, where they were like, they had to put a pause to the vaccine trials for a second because they were coming up with a couple of these outliers, and they wanted to make sure that it wasn't something that that was going to be happening more. So they had to investigate the symptoms of some people. So it, again, all this stuff has to do with what we're talking about, what's going on in the world right now. All right, so these last two, these are called skewed graphs. This one would be skewed left. And that's because we can see it kind of drops off as it goes to the left. Oh, it says I lost my connection again. The last one here would be skewed right. I don't know if you guys can see me or not. Doesn't look like it. Maybe. Oops. Skewed right. And we can see that that trails off this way. Okay, actually, I think I'm good. I made it. It came back. It says that I still have my stuff here. All right, last little bit. These ones are actually the easiest, I think, out of everything. It's called the standard deviation, which we talked about a little bit earlier, about where it kind of comes from, how we can calculate it in the computer. But a standard deviation follows our normal or our symmetrical statistics. So the mean, again, I don't know why this is so far up there. The normal distribution, it follows a smooth, symmetrical, bell-shaped curve. So it's nice and even. We like that data because it looks so nice. The total area under the curve is 100%. So that's following our statistics or our probability of something happening. They like data to tend to follow a bell curve. They used to try to get people to change grades to follow a bell curve, but we've decided, or educators have said, that that's not the best because we don't want everybody to be grouped in the middle. We would prefer that you guys understand and actually comprehend the information, and we don't want your grades reflecting a statisticalized, I don't know how to say that, curve, a nonsensical curve, if that's not where you're actually showing us your abilities. So education has come a very long way. It still has a long way to go, but in how we track and record and understand the data that we get, of you guys being able to comprehend the information that we give you. So that was a lot of big words there. So standard deviation has to do with kind of how it follows and retreats from this mean, or from the central part of the data. So this, I said this wrong earlier. This is our sigma. I think I said it was mu. Oops. There it goes again, doing that thing. Try that again. Mu looks like this. It's like U, but it's like with a super long tail. I get my Greek letters confused sometimes still. So anyways, the total area of the curve is 100%. The 68% of the data lies within one standard deviation of the mean. So this being our mean, the middle, this would be our first on the left. I'll use a different color, maybe. On the left, we have within 1 standard deviation, so meaning 1 to the left or 1 to the right. 68% of the data lies within that first standard deviation. So because it's symmetrical, 34% on one side, 34% on the other side. These numbers never change. The 34%, 34%, this would be 13.5%, 13.5%. So all of those values are always going to be equal or even. It looks really weird when you're looking at it like this. It's actually really easy to read because we know that these values are always going to be the same. So how to read a bell curve or how to make one of these work. So here we have a normal distribution has a mean of 64% or mean of 64. Hopefully that's never a test score because that would be pretty low. Why is that not letting me? There you go. So you put your mean in the middle, and then it says it has a standard deviation of 7. So that means if we wanted to know what this bar, this line was right here, we would just do 64 plus 7. And so that would give us 71. If we wanted to know the bar on the left of it, we would just do 64 minus 7. And that would give us 57. If we wanted to know 2 standard deviations, then we would just add 7 again. So I could just do 71 plus 7. So that would put me at 78. If I wanted 2 standard deviations to the left, oops, not 71. I would do 57 minus 7. I would just subtract twice. So that would put me at 50. If I wanted to know the last standard deviation, I would just add it again. So this would be 78 plus 7 would put me at 85 here. 50 minus 7 would put me at 43. And again, these values between the curves are always going to be the same. This is always going to be 34% and 34%. From here to here is always going to be 13.5% and 13.5%. From here to here is always going to be 2.35%. Same thing here. It's equal, it's even, it's symmetrical around the curve. And then this last little bit that you kind of see tailing or trailing off, this is actually a teeny tiny, it'd be 0.15%. It kind of gets neglected. Oops, I put my decimal point in the wrong spot. Hold on. Because I don't really need the 0. 0.15%. So that's kind of how it always will look with those percentages. So now we're just going to read the graph. So it says we want to know what would be the probability, so the percentage, that something is selected between the given interval. So I want to know between 71 and 85. So I'm going to come up here and look at the graph. Here's 71, here's 85. So I'm going to just add those two percentages together. So I'm just going to take my 13.5% and add it with my 2.35%. And that's going to give me my answer. I'll be at 15.85%. That's the probability based on this bell curve that something lands in between that range. So what's the probability that something's less than 57? I would just add all three of these together. I would add my 13.5%, I would add my 2.35%, and I would add my 0.15%. So I already know I'm at 15 plus the 0.15, that would put me at 16%. So there's a 16% chance that a number is less than 57 based on this bell curve. At least 57, so that means 57 or more, is what it's talking about there. Parker, are you in your Wise Guys? At least 57, so that's going the other direction. So you could add all of these numbers up. We could add our 34 plus our 34 plus our 13.5 plus our 2.35 plus our 15. Or, so I'll write that in there. Why not? Actually, I'll type it in there because I can do that faster. Maybe. If my mouse decides to work. It's like one or the other. I don't get both for some reason. So I could add my 34% plus my 34% plus my 13.5% plus my 2.35% plus my 0.15%. Oops, it's supposed to be plus. I could do that. Or, since I already know that it's 16% under 57, if I want to go over 57, I could just take, I know it's 100% of the data minus the 16%. So I would end up with 84%. And if we weren't sure, we could double check. 34 plus 34 is 68. Plus 13 would be 81.5. Plus 2.35 would be 83.85. Plus the 0.15 would be 84%. So it's different ways of doing the same piece of information. And then lastly, what's the data? What's the statistics between 57 and 71? So between 57 and 71, from here to here, I am right underneath that bell curve that's 34 and 34. So that'd be 68%. Boom. There's my data. So those values, no matter what, if it says it's a standard deviation, those are the percentages you're going to be using. And then it's just calculating some information based off of that. So number 9 on the homework is basically doing exactly the same thing. You've got a bell curve. So you're going to keep that 34, 34, 13.5, 13.5. You're going to keep all of those statistics on there. You're just changing the numbers from your mean and your standard deviation. That's the only thing that changes on there. So you guys have about 15 minutes. I would go through and at least do one of the 1 through 4 and make sure that you know how to enter that into either a calculator or into the statistics calculator online. Especially if you're entering it into a calculator, it goes really fast. And that way then you guys, if you have questions about how to read or how to write any of those things, you can do that and ask me questions so that you're ready for tomorrow. Tomorrow we're going to just look at, I'm going to give you the graphs and you're going to be able to interpret the data. And then again, Friday we'll just wrap up anything from there. Okay? So I'm going to stop sharing and actually take attendance because I haven't done that yet. And we'll go from there.